In this video we're going to introduce triangles. You would have already seen these triangles in primary school. If you're coming to this in first year, equilateral, isosceles, scalene, equilateral, all sides, all angles are the same. Isosceles, two sides are the same and the sides opposite them. You can see this side here is opposite this angle and this side is opposite this angle. It's always the sides and the opposite angles. And scalene, nothing is the same. No sides, no angles, nothing's the same. We've seen right angle triangles in our study in algebra with Pythagoras. If this is A, this is B, and this is C, you guys know that A squared plus B squared is equal to C squared. And a right angle triangle can be isosceles or scalene. We could have two 45s in here, would make it isosceles, but we could also have a 40 and a 50, which would make it scalene. So the only isosceles are the two 45s. The Greek word hypotenuse is thought to derive from the Greek hypo. Some here are hypo, under, and to stretch. So an isosceles triangle. Let's have a look at the two statements above because we can get a theorem from this. A triangle that has two or more equal sides is isosceles. Two or more equal sides is isosceles. Remember that? Two or more equal sides is isosceles. In an isosceles triangles, the angles opposite the equal sides are equal as well. So this is the angle, this side and this side we could label with X or both the same letter to give us one variable. And combining the statements we get the following theorem. In an isosceles triangle, the angles opposite the equal sides are equal in measure. Conversely, if two angles in a triangle are equal in measure, then the triangle is isosceles. And you can see the donation here, just this straight line to donate that these sides are equal. And the word isosceles derives from the Greek iso and skelos, the same leg, because an isosceles triangle looks like two human legs on the ground. If your legs are the same length, if your legs are not the same length, you could be a bit bockly, you could be like this. So now angles in a triangle, they add up to 180. So the junior certs of 2021 are the first years where they don't have to prove this. But let's look at the proof behind this, because I think even if you don't have to actually prove it for an exam, does that mean that you don't have to prove it? Well, it does for an exam, but what about just in general? 1, 2 and 3. Let's label these angles. So we want to prove that the angles in a triangle add up to 180. So to prove, so this is the old, you're going to have this to do with leaving cert, so you may as well practice now to prove angles in, and I'm going to use a simple triangle, add to 180. So what I'm going to do is I'm going to say given triangle A, B, C, given, what have we got? Triangle A, B, C. I'm going to do a construction. What am I going to do here? I'm going to construct something to help me. Construction. And I'm going to label my A, my B, and my C. And I'm going to draw a line. And I'm going to call this line DE. So construction, draw line DE parallel to BC, and I'm going to label this now. That's parallel to that. So now you can see we have alternate angles. We could bring in corresponding angles if we needed to, but what I'm going to do here is I'm going to label this number 4 and this number 5. Okay, so we want to prove, we want to say that angle 1 plus angle 2 plus angle 3 is equal to 180. So what do we know? Here's my proof. Well, I've got a straight line up the top here. So what can I say about 4, 1 and 5? Angle 4 plus angle 1 plus angle 5 is equal to 180. Why? Because of a straight line. And I do want you guys to be able to prove this. I'm going to examine you on it, even though it's not on the junior cert course. Angle 4, we can say, thinking of the answer and writing it, angle 4 is equal to what other angle? You can see here, angle 2, you've been studying alternate angles. Why? Because they're alternate. Because the lines are parallel. What can we say about angle 5? Angle 5 is equal to angle 3. Also alternate, so I can just do my two little dotted lines. So what I'm going to do is I'm going to replace 4 and 5 with angle 1 and angle 2. So therefore, or this implies that from this line here, 4 plus 1 plus 5, I'll just write it out again, 4 plus 1 plus 5 is equal to 180. Now I'm replacing 4. You told me 4 was equal to 2. So angle 2 plus angle 1, 5 is equal to 3, plus angle 3 is equal to 180. So 3 didn't appear, equal to 180. So that's QED, quadrat demonstrandum. We have proven that the three angles in a triangle add to 180. So getting your head around these types of proofs, the reason they were on the course is it really does help you with the whole study of geometry. So I want you to be able to prove this. It's really simple. You're just dealing with a straight line and alternate angles. And also in this video, we're going to now look at the proof of the exterior angle in a triangle is equal to the sum of the two interior opposites.